So, the dipole moments of compounds, dipole moment is directly proportional to difference in electronegativity. Similarly, in ionic substances, which we call as very highly polar covalent compounds, how to compare ionic nature? Look here. F minus O2 minus N3 minus C4 minus. Among these ions, the sizes, the radius among isoelectronic species F minus, O2 minus, N3 minus, C4 minus. These are all isoelectronic. Isoelectronic in the sense they have equal number of electrons, 10, 10, 10, 10. Among isoelectronic species, more is the negative charge, more negative, more size. More negative, more size. So, the radius of F minus smaller than O2 minus, because greater the negative charge, biggest is the size. And of course, opposites are opposite. I need not say more positive, less size. More positive, less size. So, among isoelectronic species, more negative, more size. This is one principle that helps you in finding ionic radii. And second principle in continuation to that is small cation more covalent. Small cation more covalent. What does that mean? Suppose a compound in which the cation is small, for example, you have LiCl, NaCl, KCl, NaCl, KCl, or BCl. So, which is more ionic or which is more covalent? So, ionic nature, what happens? Small cation. Among them, you know, Li plus is the smaller one, Na is bigger, K plus is still bigger, Rb plus is still bigger. So, smaller the size of the cation, small cation more covalent. Therefore, ionic nature goes on increasing. RBCl is more ionic than KCl. That's why I always tell you, it's not possible to brand a particular compound as ionic or covalent. I can only say this is more ionic than that or less ionic than this. Ionic nature can be only relative, but absolute ionicness perhaps is very difficult to decide. But of course, you can say all compounds formed by elements of 1A, lithium, sodium, they are perfectly ionic. But LiCl has more covalency. What does it mean? Lithium being a small ion, LiCl minus. So, what happens is, this positive charge, since it is very small, the negative charge is once again attracted. Lithium no doubt gives electron to chlorine, but it also pulls the electron more towards itself. It is very highly polar, but not very highly polar. So, lithium gives and takes. What is that give and take nature called? Giving and taking. That is nothing but sharing. The sharing nature is called covalency. So, among isoelectronic species, more negative, more size, more positive, less size, more positive, less size, and small cation, more covalent. Opposites once again are opposite. How? What is the opposite of small cation? Small cation, small anion. The opposite is small anion, not large anion. Don't change these two. Either change small or either change cation. Take the opposite of this or the opposite of that. Small cation, large cation. Small anion, large anion. Now, compare the ionic nature of these: fluoride, oxide, nitride, carbide. Which among them is more ionic and which among them is most covalent? Let us see. Small cation more covalent. Small anion opposite. Small anion more ionic. Small anion more ionic. Therefore, small anion, this one is more ionic, F minus is more ionic, C4 minus is more covalent. Therefore, once again, ionic nature also, fluorides are more ionic than oxides, more ionic than nitrides, more ionic than carbide. And it is common sense to understand fluorine doesn't have the tendency to share with others. It will, if necessary, it will forcibly take the electrons of others, being most electronegative. So F minus doesn't easily part with its electron. Even if the other one, here Cl minus is still giving something back, but if it is F minus, perhaps F minus will not give to lithium plus. So you take the fluorides of the same element. Here I have taken chlorides of different element. I have kept the anion the same, Cl minus in every case. I have changed the cation, but this time I will take LiF, LiCl, LiBr, Li. So lithium's tendency, lithium being small, it also wants to take the electrons back, but F minus doesn't give that easily. Therefore, ionic nature here, fluorides are more ionic than chlorides because small anions more ionic, small cation more covalent, small anion more covalent, small anion more ionic. Therefore, F minus is more ionic. So just use these two principles among isoelectronic species: more negative, more size, small cation, more covalent. Of course, this is called the Fezan's rule. The name is not necessary. The application of the principle is necessary. Name is not necessary. And they say Li plus gives and takes it back, and claiming the charge back is called polarizing power. Claiming back, that is called polarizing power, and that polarizing power is once again polarizing power is an indication of covalent nature.